In this practical, we will look at the operations of a fractional distillation column. We will study two cases, at total reflux and at partial reflux. This is the equipment we will use for this experiment. Note that a complete fractional distillation unit consists of more than just the distillation column. Clearly, there is the distillation column. In this experiment, we will be using a tray-type column. At the top is the condenser, which condenses the vapors generated. At the bottom is the reboiler, which boils up the liquids to generate the vapors. The feed is stored in a feed tank and is pumped into the column via a feed pump. The objective of this experiment is to separate ethanol and water. This is achieved by feeding the liquid mixture into the fractional distillation column. The final product obtained from the unit is a distillate stream which has a high concentration of ethanol and a bottom stream with a high concentration of water. This separation is achieved through a stage-by-stage operation. Consider the first stage. The vapor stream YA has a higher concentration of ethanol than the liquid stream XA. This is as the ethanol has a lower boiling point and is more volatile. As the streams continue to move up the column, the vapors generated becomes more and more concentrated in the more volatile component, and thus the high concentration ethanol stream is produced. Theory for fractional distillation. The main objective of fractional distillation is to separate the components of a liquid solution. Separation is possible as the components distribute themselves differently between the vapor phase and the liquid phase. You can consider that some components are more volatile than others and has a higher tendency to become a vapor. For each tray, what controls the respective compositions of the vapor and liquid streams leaving the tray? The compositions of YA and XA are considered to be in equilibrium. As ethanol is more volatile, the composition of ethanol in the vapor, YA, will be higher than the composition of ethanol in the equilibrium liquid, XA. Again, the vapors get richer and richer in ethanol as they move up the column. What happens on each tray? How does the vapor and liquid phases interact? The liquids are forced to flow across the surface of the trays due to the alternate arrangement of the downcomers. The vapors approach the tray from below and moves through the sieve holes. They bubble through the liquid on the surface of the tray. This is the interaction that occurs to allow the redistribution of the components between the two phases. The vapor and liquid stream then leave the tray due to the density differences. Their compositions, YA and XA, are in equilibrium. We now look at the equipment for a fractional distillation unit again. We have the distillation column installed with trays. The purpose of the tray is to encourage good interaction between the vapor phase and the liquid phase. The vapors will flow up into the condenser, which will condense the vapors back into a liquid. This liquid can then be extracted as the distillate stream or returned to the column as reflux. This reflux stream creates the liquid flows down the column. The liquids which flow to the bottom of the column is boiled up in the reboiler to generate the vapor flows up the column. It is the operation of the reboiler and condenser together that controls the operation of the distillation column and the final outputs obtained. Of course, we have a feed tank and a feed pump. Note that the feed is usually added somewhere in the middle of the column. In this practical, we will test for the concentration of the various streams entering and leaving the fractional distillation unit. We will review if the concentration of the ethanol in each stream is as per expected, that is, top product to be high in ethanol, feed to be average in ethanol, and bottoms to be low in ethanol. How will we determine the concentrations of the samples, since they are all clear colorless liquids? They all look the same. In our experiment, we will use lab instruments like the hydrometer and the refractometer. Let's review the learning points from this experiment. The objective of fractional distillation is to separate a liquid mixture into streams of high concentrations in each component. This is possible as the composition of a vapor is generally more concentrated in the more volatile component than the liquid. As the mixture moves higher up the column, the vapor gets richer and richer in the more volatile component. And we assume that the vapor and liquid streams leaving each tray are in equilibrium. Thank you for your attention.